And the stationarity was one of the properties that we have discussed. Stationarity means that some statistics of a random process remain invariant with time. For instance, if the mean of your random process is not changing with time, we call it stationarity in the main sense. Or if the power, instantaneous power, is not changing, we call it stationary in instantaneous power. Now, if you have a memoryless time invariant system, if you have a system and is memoryless, and if it is time invariant, a memoryless system means a system that the output y of t at time t only depends on the input at only the same time. So this means memoryless. Time invariant system means that if you put a delay of, let's say, if you put your input x of t, you put a delay at the input. So that means that if you give x of t minus 2 to this system, you get one output. Let's say I call it y1 of t. Now, if I put x of t to my system, to the same system, and then you get an output that you'll get, let's say, y of t here, and then you put delay of 2, then you get y of t minus 2. So if these two outputs, y2t and y1t, they are equal for all possible delays, all two, and for all possible input signals, then I call this system time invariant. A time invariant system means that doesn't matter if you put delays at the input of the system or if you put them at the output of the system. It means that it is time invariant. That means that this system has the same behavior today, tomorrow, or the day after tomorrow. So it means that the system is not changing. Time invariant system means the system is not changing. A memoryless system means that a system which does not have a memory, the system does not remember what was the input in the past, and it has no clue of whatever is going to be the input at the future. Now, if you have a memoryless time invariant system, any stationarity as a property of the input random process will be inherited to the output in another form. So we say that any memoryless time invariant system, if the input is strictly sense stationary, the output is also strictly sense stationary. So if I have a system which is both memoryless and time invariant, if x of t is strictly sense stationary, the output y of t also shall be strictly sense stationary. The proof of this theorem is trivial because any statistic of the samples of the output is another statistics of the samples of the input. So these statistics are not changing with time delay because the system is not changing with time delay, nor the statistics of the input. And the statistics of the output somehow are the statistics of the input via the relationship established by this system. So in other words, a memoryless time invariant system, a strictly sense stationarity, will be inherited not only to the output, but also the input and output will be jointly strictly sense stationary. So as long as you have the two properties, memoryless and time invariant. So this is an important theorem, and the proof is trivial. We won't prove it.